Part of the engine?
To me, it was always, since the beginning, it was feeders. The reason for that is that it's an idea that I think people would never think it would work, or the customers would take it, but basically you put the burden on the customer to say, on the client, whoever's using the rules, to say, okay, you tell me what the values are, right? And I would have never thought that it would work. I mean, it would fly with the customers, right? But it does. It's one of those brilliant ideas out of the box. Out of
just super elegant.
Yeah, super elegant, and it's not.
A lot of people have difficulties.
It's
really the business people knows their own logic.
Right.
That's the basic concept.
And they know how to do it. And I think it's hard for people to think that would fly. That's why people throughout the years have criticized feeders a lot, right? And they have tried to say, okay, it's too difficult, whatever. But it's a very simple idea, and very powerful at the same time.
If you describe it well, it is exactly that. Like we try to put it in the context, rather than acting like it's hard, or where you put it in the context of like explaining how powerful TM1 is, and like feeders is a big part of that. Like you get all of that power because it does have feeders. If you didn't have the feeders, it wouldn't be as powerful. So like. They're amazing, actually. So it's worth understanding how they really work.
Yeah,
we always say if you understand feeders, you probably really understand TM1 as a developer.
Right, and you understand why it's so
fast. I always try to find some kind of analogy to feeders. I mean I relate that to some other known technology, like a relational database, for example. And to me it's kind of close to when you define constraints and some
triggers of some sort.
Triggers and constraints within relational databases that you need to know what you're doing, right? But that's kind of the analogy.
Yeah, it's really a way of the customer.
You have to understand the model, and you have to understand how you're going to use
But the thing is, you need to understand the model anyway if you're going to build complex.
Exactly.
Solve problems. So it's not.
But it's at that level. It's not at the structural level. It's not at the use level. It's in the middle. It's you have to understand both, and then you create some rules in the middle, and that's kind of a.
Don't put my own feeling in there. I think many never consider that as a real limitation. I don't think he never considered that's a limitation. That's how customer will interact.
Mm-hmm. What I'm saying is, I think it's hard for an engineer to come up with that idea, right? Because you have to know your customers to come up with an idea like that. That okay, they can do this.
Yeah.
As an engineer, you would think, I cannot do that because
this is crazy.
This is crazy. I mean, I'm telling you to do what. So everybody always tries. Throughout the years, I've always heard, automatic feeders. And it never happened because it's very difficult to do it automatically.
You can do a certain degree, but
you can do it to a certain degree, but
there's a certain percentage of them you could, but then lots of them you can't. The real
that's a trust to your customer and the partners that you have. But anyway,
to me that's the big.
That's the coolest thing.
That's the coolest thing in TM1, and it took me a while to understand feeders. Actually, I mean, when I got there at the beginning, I got one of those books, and I understood everything. Okay, this is not relational, but it's like, okay, you can pivot and you can do this and that and the other. But then I heard the word feeders, and there was some explanation there about feeders, but I couldn't quite get it until I went into the lines of code and I saw what it was doing. I was like, this is what it's doing.
You learned it by actually seeing the source code.
By actually seeing what it was doing, and I said, okay, this is what feeders do. They just basically you put a mark in there. There's a value here. You put a bit in there. There's a value here.
I think the coolest part to me was the multidimensional, the handling the multidimensional concept plus the handling sparsity. There was really the Zen. This very Zen-like Okay.
Zen-like.
Yes,
Uh-huh.
because it's you know how like the Taoist or the Zen, they always talking about a something that has no empty space is useless, right? So you need to have empty room for people to use it.
Mm-hmm.
Okay, so this is like a multi-dimensional empty room, and then the customer put data in and play with. Now, the thing that the particularly interesting is that, you know, because we learned this in linear algebra in school to understand the Hilbert space, understand multidimensional space and all that, right? You really don't distinguish X, Y, Z versus time or versus you know, any arbitrary dimension. But the business people, you didn't understand that. They actually naturally understand that there's a multidimensional space. And this is just give, you know, a kind of like a Zen-like tool, give to them. So this is amazing, right? So
Like a business user naturally thinks of their business in the multiple dimensions
they
of
don't
their business.
describe us in mathematical terms. This is
Yeah.
a Hilbert space, or
Yeah.
this is multidimensional space.
Yeah.
They just understand I have dimensional. In business point of view, I have accounts, I have products, I have you know.
They don't
those-
even call it dimensions.
They don't even call it dimensions,
Yeah.
but just, you know, all kind of different things, right?
Yeah.
But you fit into they naturally understand that, and but this you know, this mesh together from mathematical point of view, it's multi-dimensional space, and you hold the, you know, the structure for them to put their data in and manipulate, and you handle all the complexity and the sparsity, and the customer just deal with their data.
That's
Yeah.
the cool bit.
That is pretty amazing, right?
Yeah, I mean the relational database mathematical foundation is set theory,
Yeah.
basically. and this is this algebra of you know, multidimensional theory and all that,
Yeah.
and I bet you there's
You
a
can
lot of
probably-
things to discover from the math, from the algebra, and how, you know, you can enhance the tool with the, you know, with the math, this math inside, right?
Right. Yeah, you're saying that we could, you know, theoretically, somebody put in more time. They
Exactly.
can actually formalize
To
more
formalize it
theory.
mathematically, the things that you can do with the tool. right?
Yeah,
So,
yeah.
So you said feeders, you said skip check algorithm. Basically.
Well, skip check
Is that what they
the-
call it? I mean, that's
Well,
what we
skip
call
check
it
is
sometimes.
Well, skip check
check
is a feeder.
Is feeders, yeah.
Okay, I'm just saying that the multidimensionality
Yeah,
and the
the
sparsity.
philosophically,
Just
it's more like
It's
philosophical.
really the philosophical collection of the empty space versus customer understanding their data. So you provide a tool for that.
Provide them an empty space to better understand their business.
That's
Yeah,
right.
it's interesting. That does sound Zen-like, I think.
Yeah.
You can
Right,
frame
if
that
you think
phrase.
about it, if you build a cube, I mean, I'm doing the latest testing. I just built a 7-dimensional cube, each one with 1,000 members.
Uh-huh.
But you can put just like one value in, and you ask it, to give me, you know, give me just multiply all together, give me just one, give me the value,
Yeah.
right? But don't want empty ones. So you just come back like this. Of course, because there's only one cell, right?
Yeah.
So yeah, it is kind of like empty space until customers start putting things in. Right.
Mhm.
So that is pretty interesting. It's a very useful tool.
Yeah. Did you have something then, Roger, that you'd say was the coolest, that was different than those, or not?
What about your debugger?
I mean, I was there only 4 years, so I was
Sure.
I was only exposed to the first things, and it wasn't, you know, an avalanche of new things to me, right? So I guess I enjoyed everything. The C API, it's kind of what pops up,
I
like, you
think
know,
the
all
right
these
came,
promises and all these protocols. I related a lot with you know, this binary serialization of data that we do with protobuf and all that. But I mean, everywhere I look, you know, at the things that, you know, I did those years, it was all exciting. You know, the locking, the protocol. I think the traversing of the trees.
That was funny. It was fun.
Yeah, that's because it's so simple. Once you get used to it, it feels so, you know, so natural to walk through those trees, and whatever you, I mean, when I didn't know anything about multidimensional data and sparse representation of data in trees, everything to me was a matrix, was like kind of orthogonal, in algebra, how to multiply matrices, how to add matrices, all that. And now you have a way to do the same operations from the inside out without looking at the edges, but looking at the, and learning how to, travel those paths easily with code and all that. That was kind of the.
Did Manny ever talk about that with you guys? Trying to understand, was that doing it that way? Was that just naturally what came to his mind when he first invented TM1, or is that something he kind of arrived at?
Right? That was the first pattern. How to represent the data in a optimal structure. Right?
Well, I think he always said that at the beginning it was just a dense array, right? Just an array of arrays.
It's a dense array.
Right.
It was called a PA handle, right? PA hand. That was one of the first libraries that was encapsulated into the PA hand. You use a hash table and to do some things, and then you use the tree hand to do the actual trees.
Yeah,
I think if I take a step back to maybe help what Roger said, he really enjoyed the technology advance we're building at the time. When he was there, he get to do a lot of functions. We're just making big changes. I mean, we have a lot of things that's if by industry standard, we're like way ahead of the time, right? Since you're talking about now, people started talking about this. So we're doing it. We're not calling that. Yeah. I mean, to be honest with you, one of the things I was talking to Manny before, we never bothered to do patents at that time. We could have easily done, each of us do, 5 or 7 patents.
Yeah.
Yeah.
Okay.
So you guys invented that many new approaches you think
there's
that were
a lot.
interesting
I
or
remember
novel?
the first year. I remember trying with balanced trees. I implemented the tree library with red-black trees, with all other type of balanced trees, with binary trees. I did a lot of experimentation that first year, and I think I don't know if that's still the case. But the way the tree works today is like, depending on the size, it's either an array or a tree.
Well, that wasn't there. I don't know if they removed it.
It's there, but it's I think the
because there is a threshold bit that say, hey, now this is too big. Now it's a tree. But before that, it's an array.
You either pack it or it's loose, right? But it turns out that we had done some research that we are not getting too much.
We're not getting a lot of benefit.
It wasn't helping a lot.
Yeah, it wasn't helping.
That's probably with the 64-bit conversion that those point to verse 2
when we went to, for example, when we went to Kaggle site, when we did the new the work on the MDX engine, at that time we started to have awareness, so we patented. Right, so how we handle the the degeneration of how to representing the block in the execution. I mean, that's the one that solved the problem that now they needed in TM1.
Yeah, right.
But so we went there. We had like 3 patents.
Yep.
But we could much more could have.
Because IBM,
nobody was doing nothing.
You just weren't thinking about it. IBM's really into patents, though.
IBM is whenever you finish something, they are like, okay, think about all you have done and think if you can make a patent out of that.
Yeah.
And sometimes, a lot of times.
I'm sure we could have had like 6 or 7 patents out of Server 7 with all the TM1
site. Yeah.
Well, Manny
we didn't have the culture of getting patents for everything.
Right?
Mm-hmm.
Well, Manny, I think he had just the 2, right?
Oh,
but
2?
he could have easily had like a couple dozens. But see, like the technology you're talking about, dealing with the TCP/IP stack, dealing with the CAPI, the IOU concept, right? And later the multi-threading, how the reader-writer will, our flavor. Those things are all ahead of time. I mean, like this thing we did, like the availability on Linux, the 64-bit, the data spreading, they're all way ahead other people's products. We're just not thinking for it. It's just okay. This needs to be done. Customer needs it.
Yeah.
Yeah. I mean that was one of the reasons
and underpaid at the same time.
Yeah.
Well, I'll tell you, for example, 64-bit, right? The first one, why is HPUX? That's because the customer in Israel, they had millions of customers, and they have a 64-bit HP system.
Yeah.
So we go there.
Just do it then.
Just
for the
do it.
customer. Yeah, right.
Yeah.
It's not gonna do it.
So that's how it works. So you don't think about patenting, any of the things we did. So, but I think Roger was saying that he really enjoyed it at that time. You probably don't necessarily realize at the time there's a lot of innovation, and it's still relevant today.
We're focusing on the problems,
But
not on
the,
the
it was enjoyable.
Yeah,
Right.
that's one of the things I talk with TM1 because right out of college, in college you study algorithms and all that. And when you go work there, you're just working on that. And for me, that was normal. But then I realized, a lot of people are just doing HTML, UI, and stuff, and I wasn't that interested in those things. It's TM1 had its own memory management, its own thread model, everything. You would implement
everything.
And
We even tried to reuse one of the pre-packed libraries. That,
Well, I'll tell you one of the things we did not have, right?
and
We are not the operating system.
Yeah.
So one of the things I was
No, we're not.
I was
But you thought about writing an operating system
No.
for it, or what?
because I already knew how the Linux works at the time,
Yeah.
and Applix were already a Linux company because they have to work on Linux. I was advocating to people to say we needed to, before Star Office gets sold to somebody become free, we should just make Applix were free, and we should take the application server in house because we have enough engineers to know how the kernel works.
Yeah, I remember you were a big advocate of that.
Yeah, so we'll just take a customer's application, we can run their operating system and the TM1. Then we have a full stack from the operating system all the way through everything we use.
Yeah, you wanted to sell the hardware with TM1 in there and everything.
That's right, and
Really?
no application.
Just an appliance, just
Yeah.
everything.
Just
Just
appliance.
roll it
Exactly.
in
At
there.
that time, we
plug
was
it in.
talking about appliance.
That would,
We're thinking we should sell
TM1
appliance.
is a service.
yeah.
Well, we didn't call it a service.
No.
We call it just like
appliance.
a appliance.
I mean, that's what Netisa did after, right?
Well,
They started selling
Netisa, they
appliances.
did more than that, right?
Yeah,
I
but
mean,
the
they
same-
make them, they did massive parallelism to do things.
Right, but they
which
made
is
it's the
different.
same concept, right? Just in those lines.
Hardware as well.
But we could have done, because we have enough manpower understanding the kernel. So we could, if we have a problem, we can go back to the kernel, solve all the way to the hardware.
But did we have a problem there? I mean, would it have added that?
Very few. We don't really have a problem with the kernel.
Going back to the culture of that we had, the years I was there, the Sinper, like the first 2-3 years, right? I was focusing on big problems, solving them,
we have
innovation.
Too many big things to do.
Yeah, and so I think we were in a state of flow constantly there, right? And it's really hard to find that state in at least I haven't found it in other places. Like some small period where you can feel that you are you're
very
flowing.
dynamic.
But in Sinper was like all the time. Like all the time you were focused and producing.
Well, I think it's a matter of three things. I think is that because the customer and partners, there's more and more partner and customer come online, they constantly provide the new things that they need, new requirement, and we had a small team, and there was we don't have enough manpower to do just anything they want, and there's also technology advance at the time. Right.
So what did that look like actually though? Like were you guys just all in a room together kind of thing?
Yeah,
is that what all it was or?
We were in the same office, like in the same. Actually, we had 3 offices, right?
Yeah, we all had offices.
Had an office, but it was like one. I mean, three in a row, like
3 in a row.
And,
So
and
Right.
the thing is that it was like a well-oiled machine, right? It was everything was all the pistons were working, in sync.
I would say we were very, very efficient.
Yeah, I mean,
there's no question about that.
we produced a lot in those 2 years, a lot.
Well, the thing is that we never had enough resources.
Yeah.
Okay, so by the time I left, we had like I vetted out at least 2 years, well-planned things to do.
Yeah, I mean,
I don't think they had.
I remember sometimes going to Manny's office with, Manny, why don't we do this? And he was like, yeah, that's a great idea, but this is the list. Let's put it here. Now we got to do this here. I have a customer.
Yeah.
yeah, that needs this. So,
Sure, yeah.
That's a great idea, wonderful, but let's put it here, down here.
Yeah,
And then when we get to it, you do
the
it.
plan was on the board. It was a list, and you go through the list. It's simple.
Yeah.
Yeah.
It is.
Yeah, it's
And the other thing I always think about is people came up with agile development and all that stuff.
Yeah.
I think those days we were doing agile. I mean, imagine 3 guys sitting there, and I was doing something, and if I needed something, I would just go Manny's office and say, "All right, can we talk about this? Whiteboard, talk. Bum, 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 bum. Okay. Well, let's call Yuzu. Let's call Roy. Let's call everybody. Boom, boom. We would solve the problem or
And
talk about it.
then usually say you go implement.
And then you go implement it. I mean, that was agile. That was,
and go implement it is like tomorrow we have we need to see results or next week. It's
Yeah,
like
exactly.
now. I mean, it's
but the good thing with Manny is that you say, how long is that going to take? You say, oh, it's going to take him about a week. He wouldn't bother you with, that week. And in a week he was knocking on your door. So how are you doing?
Yeah.
He left you alone. He left you,
Right.
You go do it. You go sweat it. If you have any problems, you come talk to me. But you go sweat it and do it. Which to me was great. To me was great.
Well, I
because-
think we all really enjoy his management style, which is
Yeah.
you do it. Yeah, it's a 100% trust. They big and small, we just let you do it. I mean, that's I think people like me, I like a lot of latitude.
Yeah.
So that's one of the things.
Do you think it was kind of unusual, maybe even especially for that time, like the way he just
Oh, it is
how free
unusual
form he
to
was,
many.
or free
It
range
is
he was with
unusual
it?
these days with all the agile. What I hate about agile is the constant, asking you, okay, next day, where are you at now? Where are you at now? Where are you at now? What do you
Right.
do yesterday?
yeah,
What-
and the people who's asking,
it's
they
going
don't
to
have an
take a
idea
couple
what
of
you're
weeks.
doing,
Don't
basically,
keep
yeah.
asking me what I did yesterday.
That happens a lot. That you have a manager that is leading the whole effort, is asking you every day, micromanaging you,
Yeah,
and he doesn't have a clue of what you're doing.
exactly.
He doesn't understand what you're
That's the
doing. He
key.
doesn't understand the time that it takes, the complexity, but he's asking you every day.
Yeah.
That was completely opposite to Manny. He knew exactly what you were doing, the complexity involved, everything, and he will let you do it, and he wouldn't ask you. So it's complete opposites.
Yeah. Interesting. Yeah.
It's a bliss.
And you know you've got backup.
Yeah, you know that if you made a mistake, someone will catch it. It won't fall in the.
Yes.